Good afternoon and welcome again. I request Dr. S.K. Goyal, sir, please start today's session.
Okay. Thank you, ma'am. Good afternoon to all participants, Hamida ma'am, and today's speaker, Dr. Rima Sharma ma'am. Firstly, I would like to greet to all of you on Engineers Day. Actually, this is a workshop based on recent advances of agricultural engineering and technology for doubling the farmers' income. So basically, I think we all are engineers by profession or by doing our jobs. So for today's lecture, actually today we have a resource person from Department of Agricultural Engineering. At BHU, this is known as Farm Engineering, Institute of Agricultural Sciences, Banaras Hindu University, Varanasi. Today's resource person, Dr. Rima Sharma, is from statistics background. Actually, she is an expert of statistics. So, for her introduction, I would like to Dr. J.P. Rai sir, course coordinator, kindly introduce our today's resource person, Dr. Rima Sharma. Dr. J.P. Rai sir.
Thank you, Dr. Goyal. Is my voice reaching to all of you?
Yes, sir. Yes.
Okay. So, very good afternoon to all of you and a happy Engineers Day. All our felicitations on this auspicious day. So, to introduce Dr. Rima Sharma, she is an assistant professor at the Department of Agriculture Engineering, Banaras Hindu University, Varanasi. She has obtained PhD degree in statistics from Banaras Hindu University, Varanasi in the year of 2019. She has also worked at Indian Institute of Information Technology, Allahabad. Dr. Sharma has explored some commonly used lifetime models for the data sets generated from a one-shot device, OSD, testing experiments in accelerated live test situations. She has developed a hierarchical Bayes technique with some suggestions on prior elicitation at the last stage of the developed method has the capability to incorporate missing data, truncated data, and sensor data information. Her research field includes lifetime data analysis, Bayesian statistics, and computation. Currently, she is working on copula models and application of Bayesian statistics in agriculture. So, with this brief introduction, may I please request Dr. Madam Speaker, Madam Sharma, to please proceed with her presentation.
Okay, thank you, sir, for introducing me. And as you all know that today's topic is a statistical test and R. Okay, so I will introduce you about the R, what exactly the R is and how to use it. Actually, so many people come to me, even the teachers, ma'am, can you apply this t-test for me, or can you apply the Z test for me, for just to test the significance of their particular data. But let me tell you that this is not a kind of rocket science. Okay, if you are going for a particular software, if you're not using a software and you want to do it manually, then it might be a little complicated because you have to take care of all the symbols or notation or all the terminology that are used in the formula. But if you're going through a software, you are finding everything using the software, it is not a big task. You can do it on your own, okay? Or in today's situation when everything is openly available to everyone. So why I'm telling you about R? Because R is an open source software. That means you don't need to buy it. You can use it from anywhere at any place without any, without any cost of money, you can say. So let's just start how to download it. And just starting with very, very beginning thing. Just go into the Google and just type download. Is my screen visible to everyone? If it is not, please let me know. So just type in Google download R and what is that? Yeah. So many things are there. The very first CRAN.R project, you have to click on it. And there are many versions of the R. This is the latest version, R 4.3.1. There are many versions, R3, R2, R1.1. So day by day, they are releasing the latest version of the R. So you have to click on it. Just simply click on it. And it has started downloading. Okay, it will take hardly 1 minute, less than that to download. Let it download. all of you can do it along with me. Okay, the person who are using the desktop or system or laptop, they can do it with me. So it will take hardly this. It is about to download. Installation is also very easy. So almost this is done. Okay, this is done. Now you have to go into the download, and here you will find it. Okay, just click on it. Okay. Okay, just click on yes. It is asking for, do you want to allow this app to make changes to your device? Yes, we want. And then just select OK. Then next, and then everything, whatever the bytes your system is having, just next. And just I'm accepting the default settings, next. And it will create a icon in your desktop if you want. If you don't want to create a icon on your desktop, you can click it. Otherwise, you just leave it. And next. And just next, and this it has started downloading it. Installation has been processed actually. Okay, it is done. Now you can see an icon in your desktop. This one, R4.3.1. Actually, earlier I have one version. This is 4.1.1. Now I've installed the new version, R4.3.1. This has been installed. Now you have to open it. Just click on it. Okay. When you will click on it, you will get a screen. This is our console. Okay. Where you will get all your results. Okay. So there are two ways. You can write anything on this. Okay. Or you can open a new one, new file, new script. Okay. Here you can write all the codes and you will run the codes and you will get the results here. Okay. So because as we are talking about the statistical test in R, okay, so obviously we're going for it, but I have few questions for the audience so that I can judge their level of knowledge and accordingly I will proceed. So can anyone, ma'am, can you please turn on the mics of the students just to have the basic idea what they are having. So can anyone tell me what do you mean by the statistical test or test of significance? Anyone? Do you have any idea of it? I'm
Hamida,
not getting any.
Pardon, excuse me. Hamida ma'am, kindly turn on the mics of participants.
Yeah.
Kindly allow to speak the
Because
participants.
I don't know the level of the students, what their knowledge have about the statistics.
I am telling
accordingly,
you. I am telling you. The participants are generally scientists and assistant professors.
Okay.
Few are from few are of PG and UG students. Okay, ma'am.
Okay, few are
So,
PG and UG students.
Yeah. Most of
Okay,
the participants are scientists and teachers, assistant
Okay,
professors.
so-
Professor.
Obviously, they will be having the general basic idea of it. Okay.
Yeah, definitely.
So it's definitely, yeah, they will be having the general idea of it. So in testing of R, you know what is basically the people use, right? Jet test, T test, F test, chi-square test. These are the parametric tests. So initially we will discuss the parametric test, and if the time permits, we will go for the non-parametric kind of test. Okay. So let us start with, I have just some examples I am having. So I'm taking those things. Okay. So hopefully this screen is visible to everyone and there is no issue at all, right?
Yes.
So
yes,
So when I'm going to start the jet test, okay. So very first thing is when to use the jet test. For what purpose basically you will use the jet test. So suppose some observations are given to you and you have been asked to verify whether the mean of this particular data set or observation, or actually basically there are two things. One is your population, okay, and you want to, and someone is claiming, suppose a yield, okay, you have released some fertilizer and you were just saying that by the application of this fertilizer, the company is claiming that by the application of this fertilizer, the average yield will be 500 quintals or 5 whatever. he is making some claim. Okay. Now the question is, how will you verify the claim of the manufacturer or the breeder, jo bhi hai? How will you verify his claim? So through test of significance, we basically verify his claim. So what you will do, you will take a sample from the population, and on the basis of you will perform certain tests, and then you will verify. So if your population is of having the large sample sizes, and one more thing which people often just forget about this, you can apply the jet test only your population, your samples is coming from the normal distribution. If the samples are not from the normal distribution, you cannot go for the jet test. And another thing, the population standard deviation must be known to everyone. If the population standard deviation must be known to you. If it is not known, you should not go for the jet test. Rather, the t-test will be the better for the testing of the mean. So jet test that we are discussing here, that is used for the testing of mean basically. So there is a very simple code. So if you want to use the direct code in R, okay, so you have to install some library. Okay, there are some library in which every code is available. So the library is this library BSTA. So I have a data set. You can say this. You can say this. This is the yield from the 55 plots. Okay, these are the data of yield from 55 plots, and the yield has been claimed this 140 quintal. Okay, the breeder has claimed that the yield due to his fertilizer will be 140 kilogram or something, whatever the unit is. Okay, so there is a library BSDA. Now you have to install it. Suppose the library hasn't been installed, then when you will try to run it, how to run it? First, you will run the data set. Just I have used a variable X, and these are the observations. I've just used C, and then I have combined it. Okay, so in this way you can enter the data set into R, a single data set. Okay, these are the observations that separated by the observations by a comma. Okay, simply you have to separate the observation by comma. And how to run it? You just click this whole, select this whole, go on the console. You just have to select this all and go on to this menu, and this is run line on selection. So it will run. Okay, it will run. And if you can see whether your data has been run exactly or not, so you just type X and press enter button, and this is the your data set that you have entered. Okay. Now coming to the library, if the library hasn't been installed, see what is happening here. You just click on this library, and click on run. Okay, some warning messages are there. Okay, the loading patch is this, and this. This has been installed here. If you want to install some packages in R, what you have to do, just go into the packages. Okay, and if you want to load packages and install packages from local files. Okay, local files means going through the Google. Okay, there are two ways. You just type here. If you want to install any package, BSTA package in R. So you can go and you can download the package from there. Okay, the package is available here. So you can download the package, you can download the PDF, everything from here. And one more thing, just I'm telling you about it, how to download it. Just go into the package. Okay, load packages, you can go. And so many packages are there. Okay, BSD is also there, already have installed it. So just select into it and it will be installed into your desktop, okay, in your system. So because it has been installed, okay, so simply this is the code to apply the jet test and R. This is the code to apply jet test and R. What X here is, X is your data set. That means कि for the data set, जिसके लिए for which you have to apply the jet test. And this is the alternative is equal to two-sided. Actually, there is option, you can change it. Change it, what does it mean? When we are talking about the hypothesis, because all you know in test of hypothesis, basically we deal with the two kinds of hypothesis. One is your null hypothesis and another is your alternative hypothesis. Just one is your null, this is the board I'm using, null hypothesis, and another is your alternative hypothesis. Okay, so what is the null hypothesis? This is nothing but the hypothesis of no difference. Suppose you want to do the testing for mean. So simply we make this kind of mu is original mean of the population and this whatever has been claimed. So here the claim is 140. So initial hypothesis will be this. And what will be the alternative hypothesis? There may be three possibilities. What are the three possibilities? The alternative hypothesis, either you are making mu is not equal to mu 0. Okay. One you are making mu is equal to 0, mu naught, and one you are making either it is not equal to 0 or mu may be greater than mu 0 or mu may be less than mu 0. So it depends on the objective of the experimenter, what will be your alternative hypothesis. So in our package or in our code, which is here, let me show you it. Yeah. So this is two-sided. Two-sided means you are making mu not equal to mu naught. That means you are not just saying that mu will be greater than 140 or mu will be less than 140. You are saying that simply we are testing, it will not be equal to 140. If you want, you can also test whether it will be greater than 140 or will it be less than 140. So just for if you want mu not equal to mu naught, so you will substitute here two-sided. And what is this mu? This is the 140 which is given in the question. You have to test whether the mean yield is 140 or not. Okay. What is sigma? This is the standard deviation. This is the standard deviation that is given in the question, and this is the confidence level 0.95. Confidence level means you are taking 95% if you are taking the confidence interval. That means you are taking 5% of error. Okay. So simply you have to run it. Just click on here, and you will get all the results, and it will give you what it exactly it has applied. It has applied one sample Z test, and this is the value of Z statistics, and this is the value of the P value basically, which is called. Okay, and it is also given what alternative hypothesis it has assumed, that the true mean is not equal to 140. Okay, and this is also given you 95% confidence interval that we report in your papers. You can see what is the confidence interval. So also in addition, you are finding one thing, the confidence interval in R for your specific data set, and this is the mean of the observation, these data sets. Okay. So if your P value, because here you have taken this 0.95, 95% confidence interval. What does this mean? This is your confidence interval. No? This is the lower limit of the confidence interval, and this is upper limit of confidence interval. That means you are 95% confident that the mean will lie in this range. Okay, that means you are taking the 5% error. 5% error, matlab ki this your P value. This P value is much less than 0.05. Okay, that means we will reject our null hypothesis. If this P value is greater than 0.05, then we will accept, otherwise we will reject our null hypothesis. Therefore, here we have rejected our null hypothesis. What was our null hypothesis? That mu is equal to 140. That means the claim of the breeder is not true here. Okay, so this all we can conclude from this Z test. Now, this is okay. This is one sample Z test. Now, suppose you want to apply the two sample Z test. Choose two sample Z test. One more thing. This was the two-sided. Okay. Now you suppose you want to just change it. There are the two options. Two option is just one. I told you mu is greater than mu naught, and another I told you mu is less than mu naught. So you can either substitute as two-sided or simply you can write it greater. Greater matlab right tilt is. You might all know about it. Greater. Simply you type the greater. So it will take mu greater than mu naught. Okay. So just run it and see you are getting some result. Okay. And the P value is this 0.999. So here what you will, so this is for the right tilt test. If you want, you can just change it. It depends on your objective, what you will substitute here. So you can, one I have just greater and another you can write it less. It depends you are using left tilted or right tilted. So you just change it and click it on here. You will get different results. Okay. So it depends on the objective, what exactly you have to test. Accordingly, you will change your alternative hypothesis. Okay. Now, next coming to the two sample Z test, you have two samples and you have to just verify whether the two populations have the same mean or not. From the two population, okay, and then you will test. So for 2 sample jet test, the code is simple, jet.test. Here also jet.test, here also jet.test. Only the difference is here we have substituted one variable and here there will be 2 variables, X and Y. Okay, 2 sets of data set basically you will be having now. And again, this thing is same. And this is standard deviation of first variable. And this is standard deviation of second variable. This will be given to you and this is your confidence level. So simply you have to run it, see what is happening. Sorry, object Y hasn't found. So again we will, and one more thing about the R. Suppose here I have defined the X variable this, okay. Again I'm using X variable here. So sometimes what happen in the memory of the R, I'm writing X in this way. So sometimes it might be confusing. So in R, what is suggested, you go into the MIS, okay, and just click on it, remove all objects. What will happen, whatever there is in memory of the R while running a particular code, everything will be erased, okay, and it will start working in a new manner. So I'm just removing all the objects, remove all objects in R. So I've removed everything. Now I'm again running this variable X. This is basically we are giving data to R. This is X and this is Y, okay. I'm clicking on this. This is done, okay. This is done. So here you can see this is the value of the J statistic and this is your P value. P is less than this much, okay. So obviously P is very, very less here. So you are going to reject your null hypothesis that the mean of the 2 data sets are not equal. So this you can conclude, okay. So this was about the jet test, testing of the mean. Now coming to the t-test. As you know, for the testing of the mean, we go for the t-test also and we go for the jet test also. Now the question is when to use the t-test. Okay. So basically we will use the jet test for the large sample sizes. When you will be having a very large sample. Okay, but you don't have access to the large sample and you have to work with a small sample size. It's generally in statistics taken as less than 30, but it varies depending on the population size. Okay, so if you are dealing with the small sample sizes and you don't know what is the exactly standard deviation of the population, okay, in that case you will go for the t-test. If your population size is too large, okay, and you have a very, very large sample size, okay, you have a very large sample size, then you go for the jet test and you can calculate the standard deviation based on the sample. But if you don't have very large sample size, you must go for the t-test, okay. So t-test, in t-test again, we will see the t-test for testing of the single mean. The hypothesis will be same here also. So here I am taking one example. The example is, let me, just I'm taking the example of t-test. Yeah, this is the question. This is the question. To test if a new variety of green gram is expected to give an yield of 12 quintal per hectare based on field experiment. The variety was tested on 10 randomly selected farmers' field in quintal per hectare, and this was recorded, the data. Okay, so the breeder has claimed his new variety of the green gram is expected to give 12. So how we will just verify it? So what we will do, we will take sample from the 10. These are the observations recorded from 10 selected farmers' field. So these are the yields observed. Now we will test it, whether the claim of the breeder is correct or not. So this is the thing. This here we are starting. Okay. So we have entered the data set. This one is the data set. X is equal to C, and just in a small bracket, you have to enter all the observation by separating them with a comma. Okay. And this is the code for it. The code is simple. Initially, we have your jet.test, and here we are using t.test. And here's the observation mu, that means mean. Mu means mean. So mean is given 12. An alternative we have taken two-sided, and depending on the situation, you can change it. Whether you want one tail, two tail, left tail, or right tail. So you just simply first you run it, the observation, we have just entered the data, and let us check it whether it is running correctly or not. So this will be X. Yeah, it is running. So next, run on this code and see here the results are. It will give you what exactly the test you have run. So this is one sample t-test, and this is the test statistics 1.83. This is the degree of freedom, because the total observations are 10, so it will be just subtracted by 1, so this is 9. And this is your what? This is your p value. Now you can observe here your p value is greater than 0.05. So what we can conclude that the new variety of green gram is expected to give an yield of 12 quintal per hectare, because here we have accepted our null hypothesis. Okay. So is there any question? I mean, am I able to deliver what I want? If not, please send me in the text box so that I can change the way of presenting. Is it okay?
Yeah, I think it is okay, ma'am.
Okay, sir, because it is very difficult when you are not interacting with the audience and only you are just talking.
Yeah. Actually, I have already requested to my participants, but there is no query and no, you can say, response from participant side. So,
Okay.
Did you complete or?
No, I have a lot to complete. Let me just finish.
Okay. Please continue, ma'am. Please continue.
Sure. So this is your t-test, one sample t-test. Similarly, you can go for the two sample t-test. Okay. So two sample t-test, I have taken one example also there. Here is the example. Here we have two sets of observations. Okay, you have two different varieties, and you have to check whether the two different varieties are giving you yield same or not. Okay, so how you can verify it? You can verify it if the average yield from both the varieties are same, then you can say both the varieties are more or less same. If they are not giving, if one is giving much better, then you can say this is better or this is better. So accordingly, you will set your alternative hypothesis whether mu1 is greater than mu2 or mu1 is less than mu2. So here just we want to simply test whether whether the average yield from the two variety is equal or not. Okay. So this comes into the two sample t-test, because you can see the sample size is small here. You can check what is the sample size. This is simply by typing LENGT, length of x and y, length of x. If you will type length of x, let me first run it. X, and this is y, and length of x is 12, and I think both are the same. Length of y, and both are 15. Okay, length of x is here 12, and length of y is here 15. Okay, so now let us check it, and this is your we have just run it. Okay. And this is your t statistics, this is your degree of freedom, and this is p value. Okay. So p value you can see this is greater than 0.05. So you can conclude then the yield from both the varieties are same. The varieties are of equal quality. So this kind of conclusion you can give. Yeah, this is two sample t-test, and now another we will take example in two sample t-test. There are two possibilities. What are the two possibilities? One possibility is that the samples you are taking, those samples are paired or not paired. What does this mean? Let us explain this with the help of an example, and I would like to explain it. This I'm going on to the board. This I'm taking the help of the board to explain the two sample t-test. Yes. This is two sample t-test. Okay. So two sample t-test, what is happening? You will be having basically two samples, one corresponding to one variable x and one corresponding to the variable y. Okay. So one, you will be having the data corresponding to this, data corresponding to this. Suppose this is x1, x2, and so on, xn, and corresponding to this, you have y1, y2, and so on, yn. Okay. So in two samples, simple two sample t-test, we are assuming that this set of observation is completely independent of this set of observation. That means the two sets of observations are completely independent. Okay. Then you were going for the simple two sample t-test that we have just talked about. Okay, two sample t-test. One more assumption, this sample is coming from the normal population with certain mu and certain variance, and this sample is also coming from certain population and with certain variance. Okay. This is very important. If your samples are not drawn from the normal population, you cannot apply the t-test, because this is very, very basic assumption. Your parent population must be normal. Now the question is, how we will verify that our population is normal or not? So there is one more test for it, KS test. We will later talk about how you can verify your population is coming from a normal distribution or not. So this is the first assumption. Your population is from your samples must be from the normal population with this will be unknown. This is standard condition is there, keep unknown but equal. That means, so suppose this is sigma 1 and this is sigma 2. So sigma 1 square is equal to sigma 2 square is equal to sigma. This is very, very important condition of the t-test. Suppose you haven't verified these conditions and directly you have applied the t-test, so the result will be wrong. So this is called misuses of statistics. Without knowing about the assumption and the limitation of a particular test, you are blindly applying any test. So whenever you are going for the application of the t-test, you must verify your observations are coming from the normal population or not. And when you are talking about the two sample t-test, whether the population, one thing, obviously, the standard deviation will be unknown to you, but the standard deviation of both the population must be equal. Okay. Now you can ask how we can verify if it is unknown, the standard deviation of both the populations are, equal or not. So there is test called F test. Okay. F test is used to test the equality of two population variances. Suppose the two population, just I said, tell you this is 1 and this is 1. It is not visible actually. This is normal 1 mu sigma square. Okay, and another population normal mu 2 sigma 2 square. Okay, one population is this, one population is this. Matlab x size are drawn from this population and y's are drawn from this population. So both the samples must be drawn from the normal population. The mean and variances might be different, but this should be equal. Sigma 1 square is equal to sigma 2 square is equal to sigma, and you will verify it with the help of the F test. F test is used for the equality of the two population variances. So just in a present example, what I have done, suppose this is the thing, okay? This is the thing. Let me take one example. Example I'm taking it from here. This is one exercise part, just we will solve it. Yeah, this is one exercise. This is one example. Of two sources of nitrogen, namely ammonium chloride and urea, on grain yield of paddy, an experiment was conducted. Okay, the result on grain yield of paddy in kilogram per plot under the two soil treatments are given. Okay, this is the yield due to ammonium chloride and this is the yield due to urea. Okay, these yields are given. Now you have to test which source of the nitrogen is better, or whether the two sources of nitrogen is equivalent or not. Okay, so obviously if the average yield from the both the field is same, we can say the two sources of nitrogen are equally good. If one is greater than another, we can say this is in this way. So let us start with this. So if you want to, as you know, for the two sample test, if the sample size is less, we will go for the t-test. So here you can see what is the sample size. Let us see it in the example. I'll just show you it. On after half hour. So here we have the two samples. So first we will verify whether these are the two different samples. The data has been misplaced here. Okay. This we have the two sample. Okay. So this is one sample and this is one sample. Now we will verify whether the variances of the two populations are same or not. So this is code for that, for F test. Var dot test x comma y, x is one variable and y is another variable, and alternative is equal to value. You have to just change it as we did earlier. Two-sided. Suppose I'm just writing it two-sided. Two dot-sided. Actually, data has been misplaced from here, but there is some data. So two-sided. Just type place and let us click on it and see what is happening. Just I did this one. I haven't run the data. Okay, let me first run the data. This is the data. The data is there, and now I'm just running it. So this is given you. What is it? It is applying. It is applying F test to compare two variances. Okay. So this is the value of the F statistics. This is the degree of freedom. As you know, when you are applying the F test, there will be the 2 degrees of freedom. One for one sample and another for one sample. Okay. So there are the 2 degrees of freedom, and p-value, as you can see, this is much greater than 0.05. So here we can conclude that the variances of the two populations are equal. Now, when you have verified that the variances of the two populations are equal, you can go for the application of the t-test. Is it okay? Yeah. Then you can apply this, this code, this one, this is the code. Then you can apply this code, just click on it, and you can see in the argument. Just let me show you. Just focus on this line. Okay. This is what t dot test x comma y, mu is equal to 0. Why we are substituting? Because we are taking the hypothesis that mu1 minus mu2 is equal to 0. Just we are taking it here. The hypothesis will be H0. Sorry, is it visible? Actually, let me take another piece. Just hypothesis, what we are assuming, H0. Suppose mu1 is the mean of the first population and mu2 is the mean of the second population. So what will the hypothesis will be? Mu1 is equal to mu2, or mu1 minus mu2 is equal to 0. Okay. So this is that 0 that we have just fitted there, this one here. Mu is equal to 0. So this is mu1 minus mu2 is equal to 0. And again, the alternative two-sided I have taken. You can take it left or, greater or less, whatever you want. And here one more thing. Variance dot equal is equal to true. I have just taken. Okay. If you know, if you have verified that the variance of the two populations are same, okay, then you can place here true. If you don't know whether it is true or not, first you have to verify. Suppose you have verified, you just place it, variance is equal to true, and run your software. Okay, and it will give you the result. Suppose if your variance of the two populations are not equal, then you cannot go for the t-test. There is another test. What is that test? That is called Welch test. So just you type the false, F-A-L-S-C. Okay, you type false. When you will type the false, see what is happening actually. You just run it. This is Welch 2 sample test. So when the variances will not be equal, the name of the test is Welch test. Okay, so when the variances are equal, you can go for the t-test. If the variances are not equal, you will apply the Welch test. So in R, what the flexibility R is giving to you is simply you need to change this one, whether the variance dot equals is true or it is false. So hopefully this is okay. So now initially we were talking about the independent samples. If the two samples are independent. So there is one more case, paired samples. So here we have taken the case of independent sample. Suppose your samples are not independent. Just I'm going again to the board. Sorry, this one. You have taken the two samples. One variable is X and another variable is Y. Okay. The samples corresponding to it is X1, X2, and so on, Xn. And the samples corresponding to this are Y1, Y2, sorry, the observations, Y1, Y2, and Yn. This kind of samples. y1, y2, and yn. Sorry. Y1, y2, and so on by. This is like this. So it might be possible. Suppose I'm taking one example. Suppose there is a plot. One plot is there. Okay, and you are applying two treatments on it. Just you have divided this plot into two parts. On this part, you're applying one treatment, say A, and on this part, you are applying another treatment, B. So what is happening on a particular plot? You are applying the two treatments. Okay, you may take another example. Okay, suppose you are a person. Okay, your height will be there and your weight will be there. Okay, so these are the two correlated samples. So here, what is happening? These two samples are not independent, but here, suppose like this, you have 10 samples, 10 plots you have. Okay, you have 10 plots like this, and on each plot you have divided into two equal parts, and on one plot you're applying treatment 1, another you are applying treatment B. Again, you are applying treatment A, B, treatment A, B. Like this, you are applying all this. Okay. Now you have to see which treatment is better, treatment A or treatment B, or either both the treatments are equally good. So here you cannot assume that A and B are independent, because there will be some effect of the individual plot. Okay, so in this case you will be having the paired observation, x1, y1, x2, y2. This kind of, you will be having the paired observation rather than the independent observation. In earlier t-test, what we have assumed that x1, x2, and so on, xn, and y1, y2, and so on, yn, these are independent. These two are independent. But in paired t-test, when the observations will not be independent, then you will apply for the paired t-test. Otherwise, if the observations are independent, you may go for the simple two-sample t-test. So you must be very much focused what your observation is telling about, whether the observations are paired or the observations are not paired. Okay. So there is another thing. This is again the test. This is again t-dot test. And this is x comma y, mu is again 0, alternative to y. So simply you have to substitute, you have to use another argument, and here it will be paired is equal to true. You just place paired is equal to true. So this will give the masses to R that you want to use the paired t-test. Okay. Simply you write about these are the observations. Suppose I have entered, you just run your observations and just click on it. You will be having the result. Okay. So again, you can see the p-value is less than 0.005. So you can conclude here that the mean of the two samples are not equal. So this was about the t-test and z-test. Now, just initially I have talked about whether a particular data set is following the normal. Actually, so many things are there to cover, but due to constraint of time, I wouldn't be able to cover. But one important thing, how to check the normality of a particular data set. So for this, you can go for the KS test, Kolmogorov-Smirnov test. This is also known as Lilliefors test for normality. So the code just simply I'm giving for you or giving to you for it. The code, this one, this one. Suppose this is a data set. Okay, this is the highlighted one. Suppose this is the data set, okay, and we want to verify whether the samples is coming from a normal population or not. So simply you have the test I just told you, okay, this is Kolmogorov-Smirnov test, and this is the code for this one. Okay, ks.test x comma p-norm. P-norm, for what purpose it has been used, that we want to test whether it is coming from the normal distribution or not. Actually, this norm is for normal distribution. Even though you can verify, suppose you want to verify that this is coming from exponential distribution or not. So simply you have to change PEXP. So whatever the distribution you want to verify, whether your sample is coming from to that or not, simply you have to change one argument. So this is the flexibility of the R that everyone must know actually. So just p-norm, mean, you will substitute mean of x. It will automatically take the mean of these observations as standard deviation and accordingly the alternative hypothesis, and just click on into it. and see what is happening. This is 0.886, and as you can see, the p-value is greater than 0.005. So you can, and here it is written, asymptotic one sample Kolmogorov test. So from there, you can verify whether your data set is coming from a normal population or not. So basically, today we have my objective was not to introduce about all the tests used in R, but my objective was of today's lecture is to give an idea how to proceed the testing in R on your own, rather than asking to someone to do this for me. So there is just, I'm providing one PDF manual. R provides you help also. So you just go, I'm giving you some idea. Just go into the help if you want to learn about it. Okay. So many things are there. This is manuals in PDF. Okay. So there is one manual, an introduction to R references if you want to read it. R data import, how you will import or export the data. If you will click on it, you will get a PDF. Okay. So everyone can access this PDF. Everything is given there, how to import, how to read the tables, and how to do everything in R. Okay. Now, just one important manual about which I'm just telling you. This is an introduction to R. Just click on it and you will get an PDF, an introduction to R. Okay. So when you will go inside this one, everything is given there. R environment, how does R works, what is the vector, objects, their modes, ordered, unordered, arrays, matrix, list, and the distributions are also there. See the probability distribution, okay, grouping, looping, and in probability distribution there is one sample, two sample, test also. So if you want, you can read about the testing also from this PDF. And accordingly, 36 page, just I want to show you page number 36. This is the page number 36. You can see the tests are given. So KS test and Stereo test. So many tests are one sample t-test, two sample t-test. Everything is given on this. Okay. So basically, you can use R on your own. Simply, you need to read something about it. And how to proceed in R, that already I have described to you. So many things were there, but today it will not be possible for me to cover as the time is going to end. This is all about from my side. This is 15:13. 2 minutes more I have. So one thing more I would like to tell you about R. What is the beauty of R actually? This is not only about the using the inbuilt codes in R, okay? About using the library, but R also provides you to develop your own code. If you're good in programming, okay, you can write your own code in R. There's not an issue. If you want to modify your code, you can also do that in R. So R serves at both programming language as well as a software. And the best part is it is free. It is open source software. Okay. So Goel sir, this is over from my side. Now let me know if there is something.
Thank you, Dr. Sharma. Now the session is open for discussion. Are given the necessary rights to turn on their microphones and ask their questions directly to the resource person of today, Dr. Rima Sharma. Questions are invited from participants. Please ask your question. If you have any query, you can ask. Our resource person is still here.
Yes, sir.
Okay.
We are here. Participants can ask the questions.
So I think they don't have any question. The things are actually I have talked about very basic things in R. So if they will try on their own, they can learn more about it. And if you will practice it, you will get proficiency into it, and you don't need to ask someone. You just do the t-test for me, because you have seen how simple it is. Simply there is one line code and you can get this code from anywhere. This is available. Even you can type it in on Google. T-test in R. So you will get the code. How to do ANOVA in R, ANOVA in R. So you will get the code. The only thing you just have to keep in your mind that you must know about the assumptions associated with each testing. Not even testing, in a statistics, whatever the tools, methods you are using. Every method has some limitations and assumptions. So just keep in your mind limitations and assumptions. Don't blindly use anything, because it will definitely be a misuse of the statistics. And just that is very, very sad part of today's research. Everybody is doing misuse of the statistics. Just I have noticed it, and that just I'm reporting. So you just read it. Whatever the tool you are going to use, just open the books, explore the net, and once you must read on it, and then go for the application. So hopefully this is, I don't know how was it, because I haven't interacted with the audience.
Many of us